Alright, this is about kinematics. So I hope that rings a bell. So this is physics. So basically what we are looking at would be probably three most important quantities here, which is displacement, and then velocity, and then we're looking at acceleration. Okay? Now all three of this, what is the common thing of all, or maybe two of this? How do they relate from displacement to velocity to acceleration? The time, right? So because they are all a rate, so they are all rate of change. Okay? Okay, so typically we use the letter S or X to represent displacement, V for velocity, and A for acceleration. Now since time, it is the one that is relating that three, so how do you define velocity? So first of all, we know displacement is actually a basic quantity, right? So since it is a basic quantity, so the number here, you can only obtain from your measuring tool, correct? But the velocity will be something that is slightly different because it is a rate. So a rate means it must be divided by time, right? So what you have here would be, so the velocity is now the rate of change. So the rate, so what is changing here for? It must be a displacement, right? Okay? Since we use the letter x2, you can also write this as dx dt. Alright? And what is acceleration? It's the rate of change also. So what is a rate of change of? Acceleration is the rate of change of velocity. But we also say velocity was the rate of change of displacement, yes? So this gives you the second derivative. Right? And then since this is going forward from displacement, and then you're looking at velocity, and then you're looking at acceleration, right? So this is something that, let's say if you know the displacement, and then what is its velocity, what is its associated acceleration, right? So this is how you do it. Now what happens if it is the other way around? Given the acceleration, so if you already know what A is, so A is known, how do you find velocity then? So you integrate acceleration respect to t, that gives you your velocity. Since now you know your velocity, how do you find displacement? You integrate the velocity again. Okay? So it just goes backward that way. Alright? Okay. Now two other quantities that we want to look at, which is an average velocity. What's the definition of average velocity? It must be a total displacement over time, yes? Alright? So what is the average speed? Must be a total distance over time. Okay? So which also means that there is definitely a difference between displacement and distance. Just recall, let's say, now you have done area under the graph, yes, in your integration. Let's say now if it is a VT graph, it's a velocity time graph. what is the significance of its area under the graph? It tells you the displacement. And the last time also we mentioned, if this particular area is below the x-axis, what value should you have? It must be a negative value. So it fits well here. So if your displacement is a negative value, what does it mean? It's going backwards. It's in a reverse direction. Okay? So that's how it is. That's why here, be it displacement, velocity, acceleration, they're all vector quantities. However, you still need to work with some scalar quantities like speed as well. Okay? So this is how it works. Alright? Alright? So this is exactly that same question in the book. Exercise 22.1, question 3. Okay? Now, alright, okay, let's just try this. Okay? So you're given this. Given that x is this relationship, where x, obviously, as we mentioned, that x sometimes refer to displacement as well. So you're given this 3x is 3x squared, no, 3t squared minus 4t cubed plus 60. So for the first one, is it too light? It should be okay now. Alright? Okay, so this tells the answer, right? Slightly darker. Alright, so what is the initial x? What's the initial x? Initial means what is 0? Time is 0, yes? Initial means time is 0. So when time is 0, where is this particle? Where is this body? Where is this body? Where is this body? When time is 0, it must be 60, okay? So that's exactly as what you said, yeah? So initial x equal to 60 meter because time is 0. Okay? So part B. Instantaneously at rest. What does this mean? What does instantaneously at rest mean? We don't call it speed here. We say it is the velocity. So this here velocity is 0. Okay? So how do you work out the velocity? How do you work out velocity? Alright? Okay, let's just say that again. Because x is 3t squared minus 4t cubed plus 60. So what is the velocity? The velocity is dx dt, yes? Correct? Which is 6t minus 12t squared, correct? So you say velocity is 0. At what time? At what values of t is this velocity 0? So then you say 6t minus 12t squared equals 0. Alright? So you can factorize this and say, so when time is 0, its velocity is 0. Okay, or when time is half. Okay? But what was the question asking? The question was asking for acceleration. Right? So what is acceleration equals then? You differentiate it again, dv dt. So you differentiate dv dt, which is you differentiate this thing. Okay? Alright? So what do you get? It's 6 minus 24t. Since you have two values of t, then you have to work both out. So when t equals 0, what is a? 6 meter per second squared. When t equals to half, what is a? Negative 6 meter per second squared. Okay? Alright? Okay. So part C then. So what does part C ask for? Again, I will write down x equals to 3t squared minus 4t cubed plus 60. Okay. Again, this x is the displacement. It describes how this body has moved in reference to its original position. Okay? So what you want to find out is what is the average speed. Yeah, that was the question. What is the average speed? How do you find average speed? What is the definition of average speed again? It must be a total distance. So you need to find out the distance. Alright, so how do you find out the distance for the first 2 seconds? Okay, so which is probably similar to displacement. Okay, let's try that. So when time equals to 2, what happened? Right? Then x equals to 3 times 2 squared minus 4 times 2 cubed plus 60. What do you get? You get 40, yes? Correct? So what happened here? Now do remember, let's just recall what was from previous year. What is this? These 2 pieces of the information here tells. Okay? What does these 2 pieces of the information here tell? Now at first, if you look at when time equal to 0, what happened to A? What happened to A? So A is positive or negative? Means the body is accelerating. It's moving faster. But we also say at the very beginning, the time was at 60. So when time is 0, the body is already 60 meters from that reference point. Alright? And then it is accelerating. What could have happened? So it can only mean that the body is moving further towards the right hand side, yes? It's moved further away from the reference point. But what happened at half a second? What happened half a second later? The acceleration has become negative. So it has decelerated. It is decelerating. Okay? So if it is decelerating, there must be at some time that the velocity will become 0. That's why how you got this number, because you say the velocity is 0. Yes? Why does the velocity become 0 then? There is only one reason that the velocity becomes 0, because it wants to change its direction. Okay? So if this body is moving forward, its velocity is positive, say. When it becomes 0, what is the next instant that it wants to do? It will become negative. Its velocity will become negative. It will move in the opposite direction. Okay? Right? It can only happen that way. Now, if this body, to begin with, if this body is moving negative, is moving backward, and if it has to become 0, what can happen to this body? Because it wants to change direction, it wants to move forward again. Okay? It can only be this way. Right? From negative, 0, positive, or positive, 0, negative. That's it. Right? There is no instance where you will find this body when it is positive, and then suddenly the velocity becomes 0, and then after that it becomes positive again. There is no such thing. Alright? If it is positive, it becomes 0. The next thing it has to do, it will become negative. It has to change its direction. Okay? So that's how we're doing it. Alright? Okay? So if you look at it this way, then it will be important to check out at half a second what happened to this body, or where is this body at least. Alright? So when t is half, where is this body? Then you substitute this and say, where is this? So where is it? It would be 60 and a quarter. What has happened? Now, if you are going to draw this, let's say O, the point O is the beginning point. Alright? At time equals to 0, this body is at 60 meters. Agree? That's what it says, right? Initially. Right? So subsequently, what happened? When this body starts to move, it is accelerating. It moves towards the right. Half a second later, where is he? So half a second later, it is at 60 and a quarter. And we also say at 2 seconds, where is this body? At 2 seconds, the body is at 40. So how this body has moved, it would be from here, goes all the way there, and then it comes back to this place. Right? So what is the total distance that it has traveled? So this is the purple color that you're looking at. So it would be a quarter. And then after that, it will be a 20 and a quarter, right? Which is 20 and a half. So the total distance it has traveled is 20 and a half. So what is the average speed? 20 and a half divided by 2, which is 10.25.